Hello, can you hear me? Hello.
Hi. Yes, I can hear you.
Yeah, so how are you?
Good. How are you?
I'm fine, thank you.
Hey,
Okay,
you
so okay,
feeling better?
yeah. So now let's
Okay.
start. We start first.
Yep.
Can you see my screen now?
Yes.
Okay, so hi and welcome to the monitoring water quality using technique in solar engine. So basically, for this session, I will discuss about that how we can easily monitor the LG using FAI index. So basically, it's one kind of floating LG index, FAI.
Okay.
And further, after monitoring the LG, we also talk about the correlation analysis with wind speed, temperature, and precipitation. What is the correlation? LG with wind speed, temperature, and precipitation.
Okay.
So here you can see it's one kind of chart. Basically, it show about the correlation chart between that LG and wind speed. Basically, the LG and wind speed, we try to find out that. Further, we also discuss about the temperature, precipitation. Basically, water quality parameters also depend on those parameters such as temperature, wind speed, precipitation. So this type of things also influence on that water quality parameters such as Lg or chlorophyll or turbidity or total suspended solid. So this type of things have a correlation with this type of parameters such as wind speed, temperature, precipitation, this type of parameter also. So that's why it also very important to learn about that correlation between that water quality parameter and this type of parameter, wind speed, temperature, and precipitation. So here you can see it's what kind of correlation chart. We can easily find out that it's that positive correlation. This graph show about that positive correlation. Positive correlation means that when wind speed is high, Lg or chlorophyll is also high concentration. Okay, so it show about the positive correlation, and every
Okay.
positive correlation is indicating that where wind speed is high, Lg or chlorophyll concentration also high. Where wind is wind speed is the low, concentration of the chlorophyll or Lg is also low. So it's called the positive correlation. We find out that. So let's we also discuss about that how we can easily create this type of correlation, as well as we also discuss about that how we can easily make this type of Lg concentration map using MODIS. Further, we can easily identify about that where is the high density of the Lg, where is the low density of the Lg, and further we also consider about the wind speed. Okay, we also make the wind speed map and also Lg map. Further, we try to compare where the wind speed is high. So basically this time it show about that high concentration of the wind speed. What is the situation of the Lg? Where I find out that high concentration of the wind speed. Or where is the low concentration, where is the low wind speed, where is the condition about the Lg. So this type of correlation we also try to monitor, and further we try to make this type of chart. It's our correlation chart. From the correlation chart, we are also calculated the R value. From that, we can easily get about that positive, negative, or no correlation. This type of thing we can get it. So let's go and try to discuss straight out to the session. So just I simply open my
Okay.
code. Okay. So basically, in this time, you can see this is the code. I already write the code in here. So basically, there's a lot of line I learned in here already. So basically, this time I will explain one by one and also show you some reference paper about this work, how we can easily use it. So basically, this time we are using here this MODIS satellite imagery data. So here you can see this is the one kind of data paper. So basically, this paper MODIS observation of cyanobacteria bloom in this lake of China. So here you can see this is one kind of paper. In this paper, they use that MODIS satellite imagery, and further you can see they are driving a floating Algae index. So it's one kind of FAI index. Its short name based on the medium resolution MODIS reflectance data. So basically, this time they are using that MODIS reflectance data and then further calculating the floating Algae index or FAI index. And from the floating algae also refers to the bloom, higher the cyanobacteria of the floating the scum of the water surface. So this is the actually bloom and floating algae is the same term, but bloom is also high concentration of the floating algae. When we can find out the very high concentration is called the bloom, and bloom is very harmful for our human life. Okay, so we try to discuss about the algorithm. What is the algorithm they are applying here? Okay, so here you can see this is the introduction part, study area. So this is the study area about that, and further also data source. Basically, this time they are using at the MODIS 250-meter and 500-meter resolution data. They are using here. Also, they are using at the less frequently Landsat 7 enhanced thematic mapper. Then this time we just focus on this for the MODIS 250-meter and 500-meter resolution data. And further, we are just calculate the floating Algae index or FAI index. So this is the data set, and you can see about that. For the MODIS data product development, mainly floating Algae index product, they are used in here. MODIS data set for FAI index. So you can see about that. For the first was that green, red, blue RGB color, true composite. So basically, this is the different types of band that are used in here. So for the MODIS, okay, same as we work for the Landsat imagery or Sentinel imagery, we are using the different types of band. So in this time, MODIS have also some different types of band. Here you can see this is the NDVI formula about that MODIS. Okay, so you can see NDVI derived from this equation. So different types of band we are used and then calculate the NDVI. Also, you can see about that. This is the one kind of floating index formula who provided this formula and MODIS data. So basically, in this time, MODIS band 8509 59 minus you can say RC. So this is the formula about that floating Algae index they are using here. Also, you can
Will
see
FAI work for Landsat?
FAI means it's the floating Algae index.
Yeah, will it work? Can I use it with Landsat images?
No, because
No?
this
Okay.
this formula provide only for that this you can see this is the reference. So basically,
Yeah.
this is one kind of invention or this type of things they are created, and they
Okay.
use the MODIS satellite imagery, and then they are get that better image result for the MODIS.
Okay, so specifically for
Yes,
MODIS.
specific for the
Okay.
MODIS, we have to use FAI index or floating Algae index. Also, you can see this is the formula about that RS 400 645. So this is the formula about that. Okay, and this type of formula is already invented by this. You can see about the reference also introduced by. This is the reference about that. So he used the MODIS data defined as the follow formula. Also this formula. So in this time we
Okay.
are just use this type of formula and then calculate the floating LG index. And also you can see that create this type of map. So basically when you find out that high positive value indicating the high concentration about that your floating, okay, and low positive value or negative value it's indicating about the low concentration about that LG index or LG. Okay. So let's go try to discuss about our code. So basically this is the formula, this is the theory part about that. Also you can see we also use here the threshold technique. Threshold basically we select some specific pixel. Suppose here you can see threshold of FAI greater than 0.02 was used to exclude all pixels associated with the thick LG scams. So this is the one kind of thresholding. So in this type of thresholding, we are apply and extract the specific pixel. Suppose when I apply this thresholding, FAI greater than 0.02, so it's indicating all of pixel which is the greater than 0.02 and which indicating that high concentration of the uh, LG. So this is the thresholding technique we are also used for that identify for the specific pixel of the bloom.
So is the threshold like the difference between a bloom and a normal amount
Yes, yes,
of
yes, yes,
cyanobacteria?
yes, yes, yes. Suppose less
Okay.
than all of things is the normal, but when I can get at than 0.02, then it indicating about the high concentration of bloom.
Okay.
Okay, also I think they are also developed another things about that Lancet data product development about that. Here you can see the for the Lancet equation one, they are used this equation Lancet imagery also possible. Okay, I think it's possible also for the Lancet also their main reference here you can see for that Lancet data. Lancet 7 ETM data plus where represent the this patient of with modis. Okay,
Okay.
and the equation about that. Also you can see about the result for the different time. They also calculate the area, how much area about that high concentration of bloom. They also calculate the area for the different time, different year, and also create this type of map. Timing and duration of the cyanobacteria blooms. So here type of map. Okay, so you also read this paper, then get a lot of idea about that. Okay, okay, so let's go try to discuss our code. So yeah, so this is our code about that. In this time, we are use at that notice two data set. One is that a 250-meter, one and another is the 500-meter. Okay, so two satellite imagery we are using here. And in this paper, they are also using the two data set. One is the 250-meter resolution MODIS, another is the 500-meter resolution. Okay, you can easily get
Mm-hmm.
it. Alright. So
Okay.
here you can see this is the two data set is simply import and click on here, then I can get all of information about that. Mainly they are band. So here you can see there are this type of band in here you can easily get. So one you can see surface. This is the one kind of band. Name is that surface reflective band one, band two. Also you can see about that band QC 250-meter. So different types of band we can also get from here for that. Okay, so in this time here you can see here we find out only for that surface reflectance band 1 and surface reflectance for band 2. So basically these two band we can get in here for of the 250-meter resolution. But when you can get that 500-meter, then check what happened for the band.
Mm-hmm.
So here you can get that this type of band brains. Okay, so here you can see, yeah, so you can see that reflectance band 1, band 2, band 3. Okay, also you can see about that band 4, band 5, band 6.
Okay.
Also you can see band 7. So in this time, basically, we are just combine the two data image collection. Mode is 150 and mode is 500-meter. Okay, then we create that 250-meter resolution LG map. Okay, so in this time we have the two images for the different resolution. So we are just use these two images. Suppose first image have only for the two band one and band two surface reflectance. But you can see 500-meter. The
Mm-hmm.
second image collection have the all of them. Band one, band two, band three, band four. All of bands are available. And in our calculation, we have need the all of band. And further, we also use this type of things with this image collection. Then we can get that 250-meter resolution map. So then it create our high resolution LG map. We can easily detect that LG. So this is the region to use the two satellite imagery, 250-meter and 500-meter. Okay. So then further what we can do, further we are just simply take this our study area. We take in here study area
Mm-hmm.
and we talk about the later about the wind speed. In this time it not need because we need to talk about the later. Okay. So we talk about that here you can see
Okay.
first of all filtering the modis data set. So I simply put my observation time because in this time I want to make that correlation analysis. So for that, I choose the 10 years data. Okay, year of 2010 to 2020. Okay, all of image collection I collect, and further I just use it to make the correlation analysis, because when you want to use the large data set, then we also get that more better correlation result. Okay, so in this time I just simply put here the 10 years data. So just put here the 10 years data here from year of 2010 to 2020, and then file name we are just put here the sum frequency 2021, and you can see the I simply call this image collection. So this image collection variable name is that, you can see I simply call this image collection, and further we are just simply filter bounds, then filter date, and select the basically this image collection only for the two band surface reflectance 1 and surface reflectance 2. Okay, this two band is available. So then further I use here the B01 and B02. So basically this name I just short. Further when I need this band, I just simply put here the B01 and B02. I just short this name. Otherwise it, you can see it very big name. But for this region I simply short this name. Suppose surface reflectance
Are you
1
renaming?
B01, I put here the rename as the B01.
Okay.
And surface reflectance B02, I put the name is the B02. So when I need this band, I simply put here the B01 and B02, then it come from the with this band. Okay, so this is the actual band name about that data set, and this name I just rename it B01 and B02. Okay, so after doing these things, we are just simply, you can see we need that 500 meter, basically 1 and 2, 1 band 1 and band 2, we can get the 200 meter. Okay, 250 meter resolution data set we can get it, and 500 meter band we can get from the 3 to 7. Okay, 500 meter, basically this second image collection, this image collection provide you the band 3, 1, 2, 3, 4, 5, 7, all of are available, but band 1 and band 2 I collect from that 250 meter resolution. Okay, and from this second image collection I collect band 3 to 7, because I already collect the band 1 and band 2 from the 250 meter resolution. So for this region in this
Are
time,
we using,
yes,
sorry, are we using band 1 and 2 from 250 meter because that's what the paper says? Like if I wanted to, could I use band 1 and band 2 from 500 meter as well?
no, you can also use it, but in this time we just try to create that 250 meter resolution LG map for better resolution. So for getting this better resolution,
Okay.
we are just use the band 1 and band 2 from 250 meter resolution imager, and band
Oh,
500
okay.
meter image
Because they look
collection,
better.
500 meter image collection is available for the band and band 2, but in this time we are not use it. We are just use from 3 to 7, because band 3 to 7 is not available for the band resolution 250 meter resolution is not available. So for this region 500
Okay.
meter image collection, we are just select the band 3 to 7 from this data set which is stored in here. And also you can see about that band 5, band 6, basically this is things shortwave infrared. It's called, this is the range code about the shortwave infrared for FAI compute. Also you can see about the band 6, shortwave infrared for atmospheric correction, band 7. So in this thing we'll just simply call it our data set, basically the 500 meter resolution data set, and filter bounds with our boundary, and put here the start date and end date, basically two data set, wind and wind and mainly LG. Okay, so here you can see this is the trend line about that. So it's show about that positive trend. So we can find out the positive trend. It means that higher concentration of the LG is high, where wind speed is also high. Okay. Another hand, where wind speed is low, concentration of the LG is also low about that. So it's the positive correlation we find out from the chart. And if you want to check about the value, mainly R square value or R value, so for that we are just use this code for find out that R value. So just I call the combo, which is including the two band, mainly wind speed band and also stored that another band LG band. Okay, so just I call the combo and I put here the reduce region. Okay, and use this function. Basically, this function calculate the Pearson correlation. Okay, basically R value calculate using the Pearson correlation, and this is my
Mm-hmm.
boundary name. So further, we are just calculate this type of things. We can get this type of value. We can see correlation value. We can find out the positive correlation 0.4, and we also find out that positive correlation chart look like that. Okay, so here you can see this is the process about that. We are just find out the positive correlation. It indicating that where the water the Lg concentration is the high, where we find out air speed or wind speed is also high. Okay, and where the wind speed is the low. So basically you can see, also you can compare these things from the map. Also you can see, when you open the layer, suppose here you can see it's show about the high concentration, this type of place. Okay, so this type of place we also find out the high wind speed. Okay, you can see it's show about the high G map. Okay, so this is the process
So
about that. Yeah, please.
yes, if I wanted, for example, temperature, then I would change it
Yes,
where I started the FAI. That's where I would change
yes, yes,
the equation
yes. So here you can
information.
see,
Okay.
first of all, you have to create the precipitation map. So here you can see in this time it create about the wind map. Okay, we just create about the wind map. Okay, using this data
Okay.
set. Using this data set. So you create the precipitation map first of all, and then also create about the BOD map or COD map or which one we can create. Already we will talk about a lot of parameters,
Okay.
and
Mhm.
further you are just use the same code for the correlation. Okay, you can see about that. Basically, this code is the same for the correlation all time. So
Okay.
yeah, so correlate. It will be start from here. You can see correlation. So this
Mhm.
thing is the same all time for any parameter when you want to work. Suppose in this time, what you can do, just simply change the variable name. Suppose in this time, my binary sum is stored about my LG map and wind. This variable is stored my wind map. Suppose you make the map BOD. BOD is stored for
Mhm.
the BOD variable, and precipitation is stored the precipitation variable or any variable you can put. And further, the same process. Just you have to create the two map. Which map you want to make the correlation. First of all, create this type of two map, wind speed or LG, or temperature and BOD, or total suspended solid or precipitation. Create this two map. Okay, further this two map we are just simply mention about the variable name in here, and then we create the some random point for our study. We can put here our shape file variable name. It create the some
Mhm.
band and other things, then we simply combine. Okay, just make the combo. This just select the band name about that, then it will make the combo. Store the two band in this variable. Further we extract the all of pixel. Okay, mainly all of pixel value. Suppose this type of random pixel will extract the information. What is the, for this pixel, what is the what is the BOD value and temperature, or what is the LG value and wind speed. It extract the information, mainly extract the point pixel. For each pixel it extract the information, and further we are just use the same code. Okay, then we can easily get it the correlation about that. Okay, same code we are just put in here, and this is the code we are just use here for identify about the Pearson correlation. Basically it's calculate the R value, then you also get about the R value. Okay, so basically
Okay.
this is the process about that. You also try to do for the other study area, and also check about this result, and also try to calculate the correlation for others water quality parameter. Okay, then further face any problem, then send me your code, then also correction about this code, no problem. Okay,
Mhm. Okay.
okay, so I will send you this previous recorded class and also for the today's recorded class, and also send you this practice code. Okay, and this is the reference paper about that. Okay, so this is the paper I also send you, that you also read that, then you can get a lot of idea about the LG, how we can easily use
Uh-huh.
the moderate resolution imaging spectrometer for MODIS observation of the cyanobacteria in the bloom. So you can easily get a lot of idea from here. Okay, so I'll send you all of those things. You try to practice further. I hope you can easily get this idea about that. Okay, thank you.
Mhm.
Yeah.
Yeah, it sounds great. Thank
Okay,
you.
okay, having good night. Okay, bye.